Now, here we have, guys, please. So, listening? Yes? So, consider an isosceles triangle with common side of length B and base A. What's the area? So let me draw that for you. So this is B, and then the base is A, which I'm going to split into two. A over 2, A over 2, and this is the height h. From Pythagoras, we know that a squared over 4 plus h squared equals b squared. So h will equal b squared minus a squared over 4 square root of. What's the area here? The area is half the base by the height. Now, it might look like we're nearly finished, and we are, but if you look at the question, it's not quite matched up, is it? Yeah. We need to do a bit more manipulation. So, what I'll do is I will divide or rather I shall factor out a squared from the inside. So I'm going to take a squared out in the inside. So then the b squared has to become b squared over a squared. This is the, no, I'm in the middle of speaking, so you just have to wait a second. I'm going to say why, okay? So the a squared is coming out, and it has to be b squared over a squared, because when I multiply it back in, it brings me back to b squared, which is what I have. This one is a bit more obvious. This one has to be 1 over 4. Because a squared times 1 over 4 brings me back to this. Okay, I can go back to this by multiplying in the a squared. It's the same. Yes?
Take off.
Then what do I do, right? Yes. David, why are you late? No, why are you late? Huh?
An emergency.
An emergency?
Yeah.
What? Is it really an emergency?
Yeah, family conversation emergency.
Are you in trouble?
I was in trouble like 2 weeks ago.
Okay, fine, right, sit down, so. What did you do?
Oh, you don't want to know.
I don't? Okay. Right, so this is square root a squared, square root b squared over a squared minus 1 over 4. I just split this into 2, okay? Square root first, square root second. What's square root of a squared? A. And what's a by a squared? A by a? A squared. So this becomes a half a squared root b squared over a squared minus 1 over 4. Ain't that right, Carol? Yes. You figured this out in the end, I remember. Yeah, this one. Did you get this in the end? Yeah? Satisfying? Yes. Yes, okay. Well, those who didn't get it, you can write it down now.
Are we going to have like this in the test?
No. No. I've never seen anything like this in the semester 1 test. Did you get this one?
What about semester 2?
No, not this type. I mean, there are some proofs, but they usually involve sine and cos.
It doesn't seems easier with sine and cos.
Some people like it, some people don't.
No, use what Stephen told us.
Yes, true. That's right, Ray, isn't it? Yes.
Use what we learned, huh?
Yeah. Listen to what I say.
Yeah.
Yes.
Yes, sir.
Yes,
Yes.
indeed. All right, what's next, yeah? Hang on, I just saw Carol there first. Which one?
62.
62.
Page
Page 62, yeah, no, that's clear, yeah.
Number 8.
Number 8.
Yeah.
Okay. '62, number 8. Have a look at it.
This one.
Yeah. You're definitely not talking about maths. So I need you focused, okay? Page 62, number 8. I want you to have a look at that.
This one is really,
Yeah.
I did it.
Did you get the two answers?
Yeah.
Good.
You have to
Good.
solve the equation.
Yeah, well, yeah.
I know that. It's really a job.
The problem is with the drawing. Yeah.
This problem is drawing. If you draw the diagram,
Yeah.
obviously you will get. Yeah.
Yeah. Guys, do you have that question? Now, let's have a look at it. A telephone pole has 2 wires attached to it. Each wire is connected to a peg in the ground and also to the top of the pole. The first wire is 7.8 meters long and makes an angle of 36. The second wire is 5.9 meters long. What are the 2 possible distances the pegs can be apart? Now, this might seem a little bit strange at first, how there could be 2 answers, but the reason is there is a way to draw this story. Sorry, I should say there are 2 ways to draw a picture for this story. There are 2 possible diagrams for the information provided. So the first one is kind of the one you might expect. You have a telephone pole, and one wire is here, and what do I tell you the angle is? 36 and 7.8, isn't it? And 36. And then this one here, what do I tell you? It's the length is 5.9, is it? Okay, 5.9. And the question is not the height of the pole, actually, it's the distance between the 2 pegs on the ground. That's what I'm looking for. So we have to do this question twice because I say what are the 2 possible answers. So let's get the first answer, which is this picture. So I can kind of easily get this length here, can't I? I just would need to use something like cos. I could say cos 36 equals, now what I'll do is I'll call this x and y. Cos 36 equals x over 7.8. So I have x is 7.8 cos 36.
6.3.
What is it? 6.31. Okay. Now, it actually is convenient to me to get the height, which I can now do using Pythagoras. So I could say 6.31 squared plus h squared equals 7.8 squared. Pythagoras on the left. Okay? What is the h from this? Okay, so finally, how can I get the y? Easiest way to get the y.
Sine.
Yeah, I could use Pythagoras would be the best. I can say y squared plus 4.59 squared equals 5.9 squared. Look at the right now. So what do I get for y?
3.71.
So finally, what do I get for x plus y? It's about 10, is it? Yeah, it's about 10.
Yeah. 10.
Yeah, so if I do 3 significant figures, it'd be 10 meters. Okay. Now, I'll give you a minute to write that down. There's a second possible solution that's consistent with the information provided. Did you write this down? Might be a good idea too. Yeah. got that?
No.
How was the Euclid talk earlier?
Nice.
Yeah? Did they have a like a video or of the facilities?
Yeah.
Yeah.
They just pushed us, normal sales about a pitch.
Yeah. But I mean, was it at least a good pitch?
Yeah.
Not for me.
No? Okay.
Not bad.
Not for you, but for others?
Yeah.
Now don't listen to him, like he might have weird taste. Have you seen his shoes? Sorry. I shouldn't be hitting you with the shoes. Sorry. I know they're very important to you. I'm sorry. Anyways, ignoring his comments about UConn, what did the rest of you think?
It's good.
It was good? Yeah.
I was kind of expecting more.
Exactly.
You were? Yeah.
Because it was so good.
Okay.
Like, came on with Euclid.
I don't give up. Probably like visiting this place will give you more understanding.
Yeah. UConn is a new enough university, isn't it?
Yeah, 5 years.
5 years now, isn't it?
Yeah.
And how many places do they have for medicine? They say?
100
something.
100 something?
150.
For international students.
Oh, that's good, isn't it?
Yeah, mostly international students.
They're mostly international
Yeah.
students.
Yeah.
150.
Yeah.
That's still good.
It's like
Probably expensive.
depends
Cheaper
on-
than RCSI.
Well, that's not difficult. RCSI are very expensive, aren't they? Yeah. Okay, do you have that now? Yeah. So, I know, Ray, you have the picture here for this one. I wonder if anyone else can imagine the other way to draw this story, but still matching the information provided. That is, that's it, very good. That the two wires need to be on the same. Did he just? Okay, doesn't matter. The two wires need to be on the same side.
Which question?
It's the same question we're doing. In this one here, there are two answers because there's two ways to draw this with the information given. So one possible way is you have the telephone pole here, you have one wire here, and then the other wire is on the same side. Now, obviously the longer wire is the one further out. How long is the longer wire? 7 point. So this one must be the 7.8, and this one here must be the 9. And which one is the 36 on? The 5.9, isn't it? Oh, sorry, the 7.8 is the 36. Yeah. And once again, I want this distance. Now, let me think. What would be the best way to do this? That's 36. Sine rule. Guys,
If you have a bad group.
I want only English.
Yeah.
Okay, good. You too, Aziz. I thought I heard Arabic from this table.
That's me.
No? Are you sure?
Yes.
Okay. Alright. What rule could I use here to get this distance? Cos rule?
Cos first and then.
Yeah, the cosine rule would work. What we have to be really careful about with the cosine rule here was which side to start with. In the formula, which is the beginning side. Good, the 5.9. You always, it's a bit weird because usually with the cosine rule we're starting with the unknown side. For like 90% of the problems with the cosine rule, you're starting with the side you don't know. But for this one, because the way it's set up, you have to start with the 5.9 because that's the side opposite the only angle that you know, which is 36, which is the problem. So we have 5.9 squared equals 7.8 squared plus x squared minus twice 7.8 cos 36.
Why twice?
That's the rule. You have the cosine
Ah,
rule?
yes, yes,
Yeah, yeah.
yes.
So, what type of equation is this now really with x? It's a quadratic, isn't it? So you have x squared. Oh, sorry, I left out my x, didn't I? I didn't write it in. I'll just put it here. X squared minus 2 times 7.8 times cos 36 x plus 7.8 squared minus 5.9 squared equals 0. I just took this guy over to the right and cleaned it up a little bit to make it clearly a quadratic where the A is 1, the B is minus 2 times 7.8 times cos 36, and the C is 7.8 squared minus 5.9 squared. So using the quadratic formula, you'll get two answers, but one of the answers will be ridiculous, like it'll be negative or something. And the other answer should work out to be 2.6 when you use the formula, the quadratic formula. Easier than the previous? Yes, it is, because you only need to use one rule. Okay, if you can copy that down. Now, this is actually an important example in trigonometry. It's what's called an example of the ambiguous case. You might know this word, ambiguous. Yeah. It's called ambiguous because it's not clear which of the two situations we have, because both are possible with the information given. Now, this is an advanced question. Like I said, is not something I would expect to see on the exam. They've never done ambiguous questions in the exam before. It's a little too advanced. They always provide the students with the diagram, which means that it can't be ambiguous. You know exactly which situation you have, you know. And between the two situations, the good news is, well, you said the second one was easier, didn't you? Yeah. This is the more common picture in the exam than the first picture. So practically between the two, you know, 95% of the time it'll be the second picture that they'll provide. You know, and maybe 5% of the time it could be the first one, which is good, isn't it? Yeah. Okay, write that down and we'll have a look at the next question. Yeah, which one? I think I know. Graph one? Yeah, we'll do another graph one. Did you have, which page is that now? 66, isn't it?
66, right?
Any particular graph you want drawn?
Yeah. I know how to like get the points, but I didn't know how to like.
Yeah, so which one do you want me to
The
do?
first one.
Okay, we'll do 1A. Good, okay.
So,
Yes.
How about in 3D imagination? The wires can be.
Correct, yeah. This then, if 3D was allowed, that is, the two wires didn't need to be on the same plane, that they could be separated. That's different. Yeah. Yes. Yeah. We definitely don't have 3D problems in the trig, in the exam. They're all 2D problems.
Trig.
Trig, yeah. Short for trigonometry.
Vectors and stuff. We don't have vectors.
No.
Oh.
No. Okay, can we go to 66 now? Not yet? There's the second. So we're going to do a graph example, which I think everybody would be happy to see another graph example, since they're not the most easiest for all of you, right? So we'll do the first one on 66. Now, Haza, you were saying you don't have much trouble getting the points,
Yeah.
but it's at the end, is it, where you have to
Yeah.
fit it in? Yeah. Yeah.
And how to know like between 2
Yeah, oh yeah, okay, yeah. Right, let's have a look. So what I'll do first is I'll just get the points first. Can I scroll down? Yeah? Okay, so before you start, you need to take out the 2. So you get 3 cos 2x plus pi over... if I take out the 2, what will it be here?
6.
6.
It was the most.
What do we call this now? Factor out.
How did you get this?
Yeah, it's pi over 3 divided by 2. I'm taking the 2 out. See, I have new brackets here?
So every time we take the number.
Yes, yeah. Oh, you didn't do this? That's going to affect your points, so it won't be, it'll be a little bit different, won't it? Which letter is different? If you didn't take the 2 out, which letter is different? The C. Yeah, because the A hasn't changed, the B hasn't changed, the D hasn't changed, but you're doing this to change the C. Yeah? Okay, let's make our table now. Start, end, min, max. Right, so plain old simple cost begins at 0 and ends at 2 pi, very good, and its minimum value
-1.
and its maximum 1. Okay, let's see, what is the effect of the A?
Minimum and maximum.
Very good. How do they change now?
Gonna be next to the 3.
Yeah, there we go. Okay, what's the effect of the B?
The end.
Very good. What is it now?
4.
Pi.
Pi. Good, yeah.
Why pi?
How's it, Teller?
Because we're gonna divide it by 2.
That's it.
Why not multiply?
Because that would be wrong.
Why?
We did this in class. We did. Remember I showed you the graphing program?
You know there is a thing called YouTube.
No smart.
Really?
Only I can dish out the wise crack and smart comments, okay? As David will tell you, alright? What I recommend in the class, do you remember I had the graphing program open and I showed you how the graph changed? So it'd be much easier if you watch the part where I show you how if you put a 2 in front of the x, the graph shrinks down. Okay, so it compresses down. Right, C, what changes here?
The start and the end.
Yeah, so what do you get now?
I don't know because
It's different there for you. You get pi over 6 and 5 pi over 6. You move everything leftwards pi over 6 units. Yeah, and these stay the same. And finally, what's the effect of the D?
Maximum.
-2.
Yeah, what did they become now?
-2, 4.
-2 and 4. So, I'll just give you a minute to write this down before I draw the graph. Yeah?
5 or 6.
Oh, thank you. 5 pi over 6. This is what we need to use to make the graph. So just take a minute to copy this down and we'll make the graph.
because pi.
You got that written down? Yeah?
We multiply the pi with the negative pi over 6, right?
I don't think you mean the word multiply. You subtract.
Subtract.
Pi minus pi over 6. Here, has it? Pi minus the C gives me this.
Oh, okay.
Do you have that copied?
Yeah.
Yeah. Come on, faster. Yellow, yellow. Come on. Huh?
I would copy it, please.
You sure?
Yeah.
Well, do you just want to leave a space and write down D? Because D is the one we need. Because the first is just rough work, calculations. The D, that the final one, that's the most important one. Now, this one is a little bit different because if you look at the question, you see that I want the graph to go from minus 2 pi to 2 pi.
But here's, yeah.
But here it doesn't quite go that far, does it? So, if I scroll down, I'll just leave that at the top for me. So I'll need quite a long axis here. There is the x-axis. 0. This will be minus 2 pi because that's where they say to start. And then I say to finish at 2 pi. And we need a y-axis. Now, what's the biggest number I'll need on this y-axis? 4. Yeah, so maybe I should go something like 4 here. And then this could be 1, 2, 3 like that. And then I need to make it the same. Oh, that's not quite the same. Minus 1, minus 2, minus 3, minus 4 then. So Hazza, here's my little tips for you, okay? It's nice to look at these guys here. These are both pi's over 6. This is 1 pi over 6, and this is 5 pi over 6. So if you find it helpful, you should go in units of pi over 6. So that means you're breaking your pi up into 6 pieces. If it's pi over 6, that's 1/6 of pi, right? So you should break your pi up into 6 pieces. Now, if there's 2 pi, where's pi? In the middle, right? Because that's 2 pi, so this guy is pi. And where is it here? In the middle then. Pi here. Okay? And what I'll do is I'll subdivide, you know what I mean, subdivide, into 6 pieces. Because remember I just said we're using pi over 6. So let me try and get this. 1, 2, 3, 4, 5, 6. There we go. 1, 2, 3, 4, 5, 6. Okay, so there's 2 pi. There's minus pi. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So each one of those little pieces represents pi over 6. Okay? So there's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is there. I need that one because that's this fella, isn't it? Okay. Right, so let's begin by putting in our lines. The easy one is the minus 2. Where does that go? That will be along here at minus 2. And the next one I'll do, the 4, which will be up here. Minus pi over 6. Before I draw it, I want you to see with your eye where it will go. And now we'll find out if you imagine the right spot. So minus pi over 6 will be here. Is that what you pictured, Hazza? No, I could tell from your expression. Where were you picturing it? Here? Ah, but this is minus pi. And we need minus pi over 6. That's 1/6 of pi. Pi over 6 means 1/6 of pi. So that's only going to be here. Okay, you have another chance now. Picture where 5/6 pi would be. Yeah, well, just picture it in your mind and then I'll draw it. You all visualize it? Okay, we'll find out now. Hazza? No, okay, alright. Where are you picturing?
The second one.
Here? Ah, no. That's 0. That's 1/6 of pi. That's pi over 6. This next one is what? 2/6 of pi. 3/6 of pi. 4/6 of pi. 5/6 pi. 6/6 pi. In other words, known as pi. Yeah. Next one would be 7/6, 8/6, 9, 10, 11, and this one 12/6, which is 2. Yeah.
So instead, like, put the 2 pi and negative 2 pi and apply the other things.
Basically, yeah. I start with the end and then I subdivide. Yeah? Now, what I need to do next is take this and split it into 4 equal-sized pieces, right? So this is 2 units and this is 4 units. The total height is 6 units. So if I half that height, 3 units. So 1, 2, 3. That's here. Right, now, be very careful. How wide is this?
1.
Not quite.
Pi.
Pi. You can count it. 1, 2, 3, 4, 5, 6.
So it's fine.
Which is
6 pi. So in pi.
Yeah.
So half of that would be obviously a half pi, or 3/6 of pi. So that, look, 1, 2, 3. So there we go. There's it split in half that way.
Okay.
So there's 6 pieces here. So I just split it
Ah,
1, 2,
yes,
3,
yes,
1, 2, 3. Okay? Yeah?
Yeah.
Now, very carefully, you need to copy and paste that. So 1, 2, 3, 4, 5, 6 will be here. 1, 2, 3. And again in the middle, that should be all the same. And then 1, 2, 3, 4, 5, 6. 1, 2, 3. And in the middle, ugly. 1, 2, 3, 4, 5, 6 will be just here.
Yeah.
Split in the middle. 1, 2, 3. 4 equal parts. Now, at this time, your eyes might be getting a bit strained. Can you still see the original window?
Yes.
It was, let me put little brown caps on it. It was, this guy here was the original. Right, so now you fill in your cost graph. So where does cost begin in the window? From the top, goes down, hits the bottom,
Yes.
back up to the top.
Yep.
So that would be here, down to the bottom, and hits the top. Copy, paste. Whoa, not quite, but okay, close enough. Down and up. Down and up, and there we go. That's it there, and let me just shade in. There was the x-axis, and then here was the y-axis then. So this is what I mean. In the exam, you can do your rough work with a light pencil, and then the final graph with a pen or a dark pencil. This, you have to be careful with this, obviously. You know. I don't think many of you have seen this method before. No. I don't know, I just made it up myself. It's this one here. Yeah, because I can't really find...
Yeah.
You do it this way in physics?
Yeah.
Nice. Okay. It's... I can't think of any easier way to do it. I can't think of any easier way to do it. You know?
So now you take the negative pi over 6 and divide it by what? Or by 6.
Which part?
This start.
The negative pi over 6?
Yeah.
Divided by 4? Why? Like what step are you thinking about here?
Like, I want to like spread the negative pi over 6 along the 2 pi.
Ah, okay, I understand, yeah. No, I suppose you really care about what the number in the denominator is. So that's... Where's my one? Oops, sorry. You see this 6 here?
Yeah.
In my mind, what I do is I mark off 2 pi and pi, and then I break each of them into 6 smaller pieces, because the 6 is here. So for example, if let's say this was minus pi over 4, and then the other one was like, say, 3/4 pi, then what I would do is I'd mark off 0, pi, 2 pi, and then each of these pi's I'd break up into 4, if it was this. Do you get it?
Yeah.
Yeah, because the 4 means I'm dealing with multiples of a 1/4 pi. You know, 1/4 pi, 2/4 pi, 3/4 pi.
So you take the pi and divide it by 3.
Oh, if it was like this.
And not 3, sorry, 4.
Yeah, divide by 4. Yeah. Okay, is that okay?
Yeah.
That's another example? Yeah? Yeah? How are we doing for time? We got time for more? Yeah, we can do one more.
Teacher, with your knowledge, can you draw the graph straight? Like, imagine.
I could, but I might not be right. I could have a good guess. Depends how complicated the formula is.
Just use your
Page
imagination.
56.
I think, yeah, 56? I think I have a good chance of getting it if I'm not under too much time pressure. Which one?
56.
Yeah, which one?
6 pi over 6 is 1. Number 9 and 10. When you want 6, what happens?
9, forget about.
10.
Forget about.
How about these?
6
8,
واحد على 6.
Aziz,
Okay.
La. La. Yeah? I know some Arabic. You know, I'll tell you another word I know. Kabi. Do you know this word? Do you know this word?
Yeah, it means stupid.
Yeah. And, oh, what else do I know? Chum. You know? Right?
And what is chomp?
It means be quiet.
No, shut up.
Shut up, literally.
Yeah, well, I was being polite. Yeah. So, I'm not telling you to do this, but I would like you to be quiet and use only English, okay? Yeah, you wouldn't like to know all the bad Arabic words I know. I know quite a few. Yeah? Right. So 9 and 10 are way too difficult for the exam. But 8 could be on the exam. I think I've seen 8 once on the exam. So I'll do number 8 on page 56. Okay, can you look at 56? Number 8. So basically, Karul, what's happening here is you're given an exponential and you're asked to write it in a linear form.
Yeah,
And if you do, what would be the constants? Okay, can I scroll down? Yeah. Right. Y equals A E bx then. So, to make this linear, what should I do to both sides? Log. So you have log y equals log A E bx. And next?
modify it.
Yeah, what rule of logs do I use next?
Plus and
Yeah, you have log y equals.
Log A plus log E.
Now what happens?
Bring down the bx.
Yeah?
I mean, yeah.
Yeah, you can bring down the bx. Yeah.
Log E.
Log e is what?
1.
1. Or rather, yeah? Log y equals bx plus log a. So what you can do is you can say let y dash be log y and let m equal b, and then let, well, keep x the same, call x still x. So if you were to use these substitutions,
Ym equals b.
y, which one? Yeah, well, you'll see now in the next step. If you were to use these substitutions, log y, I would just write as y dash, because remember I just said call y dash log y. B, I'm calling now m. X I keep calling as x. And log a, oh sorry, I never wrote that down. And let C, call that log a, C dash. So this would be C dash. Now this is a very fancy way of telling you something that you might have heard in biology or chemistry before. that if you have a relationship that's exponential, if instead of plotting, well, if you were to plot x and y, you would get, you know, some graph like this. If instead you were to plot log y and x, the graph would be like this. It'd be linear. That's what this is saying. Have you done that with Colm? Has Colm ever mentioned
No.
plotting on a log scale? No, he will at some point. So there are some graphs in biology that make more sense when you use logs rather than the original values. Okay? Usually with things like enzyme activity and things like this. So if you were to measure the activity and then log it and plot the log of it instead of the original, then the graph will be linear. Yeah, so the expression Colm uses is what's called plot on a log scale. Listen out for that in biology or chemistry class. Okay, it's related to this question. What are you doing in chemistry and biology at the moment? Have you done molar mass in chemistry or Avogadro? You just started, yeah. And in biology, I saw Colin had some graphs earlier today. Oh, you have tutorial now. But are you doing graphs with him?
Yeah, it's tutorial.
You are doing graphs, yeah. So what types of graphs are they? Have you done any thing that relates to the maths class, exponential or?
Not really.
No, not yet. Okay. You definitely will, anyways, for sure. Because it's an exam question in biology. I've seen it a couple of times. You know, they give you some activity or something, and you have to plot it, and it'll be a log graph or an exponential graph. And a lot of the graphs are, what are they called now? They go up and level off. That's one of them. And another graph I've seen in biology before is one that goes up and then comes back down. This is like activity and temperature or something like this. Which one is it? Enzyme and temperature?
No.
It's like the
Substrate concentration and enzyme activity. Is it? Yeah.
We see the effect of temperature and
Then it
pH
reaches
and
like
Yeah.
maximum point.
Yeah. Okay. Right. We'll wrap it up there. Are you in here for your bio tutorial?
Yeah.
Okay. Yeah.
Just one question. I did this question asks for work the height by first finding the area.
Nice. I like it.
Yeah. Then I find the area, I find the height, but I didn't.
It's not right.
No, it's right, but there's like 9 for area. Something.
You found it without using the area. Excellent. Well, there are many ways to do. Yeah, of course. Yeah, absolutely. Yeah, there are many ways to do maths problems. That's fine.
أصلا من